Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us around the globe. I'm very happy to have all of you here for our July user call. My name is Dalia and I work as a community manager here at Kong. Today, we have a very special presentation for you coming from Forum 3. We'll let them introduce themselves and tell you more about the company. We will talk how they manage Kong routes in multi-cloud environments. We have Adelina and Frederick here with us. Let's take all of the questions at the end. So please use the Q&A function that we have here on the bottom. Please put all the questions there. And as soon as they're done presenting, we will answer them. And with that, please take it away.
Hi, everyone. We're really excited to be here. Kong is absolutely crucial technology for our multi-cloud platform. So we're super excited to share our use case and teach you more about how we run Kong in a Kubernetes-native way on our multi-cloud platform. Hopefully, there will be some lessons learned for everyone, and you can take these lessons back and implement them in your own projects, regardless of whether you run a multi-cloud platform or not. So we want to introduce ourselves a little bit more. So I'm Adelina, and I'm the tech evangelist at Forum 3. As I mentioned in the chat, I'm based in London, sunny London, and I've been at Forum 3 since late 2021. So time flies when you're having fun, I suppose. I've got a background as a Go engineer, and my current focus is to share knowledge and practices, engineering practices and solutions at wonderful events such as these. And I'm here with the wonderful Frederick. So introduce yourself as well, please, Frederick.
Yeah, sure. So hello, everyone. My name is Frederick, and I'm a staff engineer at Forum 3. I've been here for a little bit over 2.5 years. And one of the great things about Forum 3 is that it's fully remote. So even if the HQ is in London, I'm able to work out of the countryside outside Trondheim in Norway. So I have an application developer background, but since joining Forum 3, I've been in the platform team. And for the last year plus, I've been focusing on the connectivity bits of our multi-cloud platform. And with that, I'll hand it back to Adelina.
Yeah, I'm not jealous at all of the awesome views that Frederick must have in the countryside in Norway. So now that you know us a little bit, we'd like to get into the meat of today's call, which is to tell you about Forum 3 and our use case. We build and run a real-time payments processing platform. So we're going to look at what that means a little bit more in the following slides. And our clients are major financial institutions that integrate with our platforms at our platform and send payments instructions from their customers to us. Then we reliably and securely process these payment instructions for them. And this obviously makes our customers' lives easier as we take care of the operational concerns of this highly regulated financial industry. Our platform is written in Go, and we use Terraform for managing our infrastructure, which runs in the 3 major clouds. From an organizational perspective, our teams are fully remote and have the autonomy to operate in a SecDevOps culture. So what exactly is a payments processing platform? Well, I promised you I'd give you my best explanation of it, but as you can imagine, the payments ecosystem is quite complex. So imagine that you have 2 friends and they have accounts at different banks. So here we've said Bank A and Bank B. Imagine that the first customer, the customer at Bank A, would like to transfer some money via bank transfer to their other friend, which is at Bank B. So how do they go about doing that? Well, we can greatly, and I really underline the word greatly, simplify the process to 4 steps. First, the initiating customer at Bank A sends the instruction to their own bank about which account at Bank B they want to send money to. Next, Bank A runs validations on the payment instruction. These could be simple verifications like whether the account exists at B, or more complex fraud verifications. We won't go into that detail for now. If all the verifications go well, then Bank A goes forward with transferring the funds electronically to Bank B. Then finally, step 4, Bank B puts the amount in the account of the intended customer, which was the friend of customer A, and the money transfer between friends completes. All seems simple and straightforward, right? Just move money from one place to another. Well, let's think about this process at scale. Each bank would need to maintain integrations with every other bank in the world. And we know there's quite a few banks out there. And this is before we even think about like different countries and all of that. So this can quickly turn into an integration and security nightmare. Instead of integrating with each other directly, as my previous diagram might have shown, banks rely on external payments infrastructure to specify the integrations and standards between banks. On this diagram, you see some of the important payment schemes, as they are called, in Europe and the UK, and our platform supports these payment schemes and some others as well. We won't go into the details of each payment scheme, but it's important to understand that they each have their own message formats and implementation details. They also make changes to their APIs, bringing maintenance burden with each integration. As you can see on the diagram as well, our platform sits between our clients and the central payments infrastructure, or the external payments infrastructure, as I've called it. We take care of the security and maintenance concerns, ensuring that the integrations between our clients and the payment schemes are working and up to regulation. And this regulation can be quite a handful to follow. Then our clients only need to focus integrating with our single REST endpoint, sending simple payloads, and then we take care of the mapping and processing on multiple payment schemes. And this is where we make our customers' lives easier, as I mentioned before. Okay, so now that we have a basic understanding of the payments ecosystem, we can turn our attention to the Form3 multi-cloud payments platform. But Form3 wasn't always multi-cloud. So I'd like to show you what we call the legacy platform. So Form3 was founded in 2006 and was built in the cloud from the very beginning. The founding engineers wanted to build a scalable platform as quickly as possible, and they believed that a cloud architecture was the best way to achieve this. Our payment services were hosted on ECS and used SQS and SNS to send messages at scale between the payment services and the payment validator and translator services. And these payment validators and translator services do the heavy lifting of communicating with the payment schemes that I mentioned earlier. And we had to run the payment services that integrate with the FPS or faster payments payment scheme separately in data centers due to regulatory concerns. Now, I've included these in this diagram for completion, but this won't make a lot of difference to what we're discussing today. The star of today's show, Kong, sits in front of the payment services, acting as our API gateway and directs cloud traffic to our payment services. So it sits between our customers and our payment services, playing a very, very vital role. And Frederick will tell you a little bit more about that as well. So let's have a look at how the Kong configuration was managed in this legacy AWS hosted platform. So we talk about route management. Routes describe the traffic into our environments, which can become complex for multi-tenant platforms such as ours. Engineers committed route configuration changes to a single GitHub repository that is owned by the platform team. Once the change is committed, the environment-specific Terraform workspace monitors for changes and plans the change. The Terraform workspace applies the change to the Kong admin API, which in turn stores routes in Amazon RDS. This approach is in line with our GitOps development practices. Our GitHub repos are the single source of truth for the Kong configuration, as well as all the other stuff that we work on. But as Form3 grew, we needed to scale the platform past operating in a single cloud. Running critical payment services means that you are very sensitive to outages and vendor lock-in. A replatforming effort was kicked off where we needed to address these issues and give our customers the option to run in different clouds. Two options for growing the platform for undertaking this work were considered. First, we could perform a full rewrite of our platform in another cloud provider, such as GCP, for example. While the second approach would be to convert our existing services to use cloud-agnostic technologies instead of the AWS-specific technologies that I showed you earlier. The first approach has the downside that it requires a full rewrite of the platform and can only be verified once the full solution has been built. The second approach allows us to deliver in an incremental fashion while keeping a single version of the Form 3 services that will work on any cloud. Due to these key advantages, we decided to take the second approach and rebuild our platform using cloud-agnostic technologies. The cloud-native CNCF ecosystem had all of the technologies we needed for our multi-cloud project, and obviously Kong could stay as our Ingress controller. Okay, so here you can see an overview of the technologies that we built our multi-cloud payments platform with. So first, we see that we are relying on Kubernetes, CockroachDB, and NATS across 3 clouds, AWS, GCP, and Azure. Customers choose which cloud they want to connect to, and then pass their payments instructions to that cloud. All of our services are now running on Kubernetes, and we make use of the managed Kubernetes offerings of each cloud provider. So this is what the diagram is illustrating. Kong is still our route management solution, but it is now also running in Kubernetes in each cloud. The data centers connect to the clouds using highly available secure connections. The last aspect of background that I would like to cover is the organization of our environments. In Form 3 nomenclature, a stack is a fully running version of our platform. In the multi-cloud world, each stack is now running over multi-cloud with connections between the payment services in each cloud. Changes move from dev to test to production, as one might expect. Our test environments, however, are customer visible and serve as integration environments for our clients to test against. Stacks are then organized into jurisdictions, which offer full data separation for our clients. And this is important to keep in mind because it will tie in with our discussion of Kong in a little while. At the same time as our platform grew, so did our engineering teams. So we needed to revisit all of our development processes to ensure that they are still scalable. I will now hand over to Frederick, who will tell you how we changed our Kong route management practices to work in multi-cloud. So take it away, Frederick.
All right, thank you very much for covering all of that background, Adelina. I am going to share my screen here, and you should be able to see the rest of the presentation here. Okay, so like Adelina mentioned, part of the challenge we faced is how can we allow for organizational scaling? How can we add more teams, more services without the platform team becoming a bottleneck like it was previously? So as we add more teams and services, we'll also need to add more ingress routes. And in this new platform, we'll have to add them to multiple clouds and jurisdictions. So how can we find the right balance here between retaining some centralized control in the hands of the platform teams and then still allowing the application teams to work independently? And the Kong Ingress Controller running in Kubernetes helped us find a model that works quite well for us. So before we look at the actual multi-cloud architecture, I'm going to cover a few background concepts around the Kong Ingress Controller itself. So the Kong Ingress Controller is the Kubernetes-native way to manage ingress in Kong. It allows us to use Kubernetes Kubernetes-native resources, such as ingress resources, but also gateways, HTTP routes as provided by the new Gateway API. And we can use these resources to configure the Kong proxy. So the Kong Ingress Controller is subscribing to updates to such resources via the Kubernetes API server and reconfiguring the Kong proxy on the fly. So as you can see here, as new such resources are added to Kubernetes, to the Kubernetes API, the Ingress controller will get notified of an event for changes to these objects that it's interested in, and it will in turn take care of configuring the Kong proxy based on the data it read from those resources. So if you remember a few slides back, Adelina showed us the previous solution we had. So let's contrast a little bit here. With this new approach, we do not have to call the admin API directly ourselves to reconfigure the routes. This is taken care of by the Ingress controller. That means we don't have to have an external Terraform workspace accessing a service running inside the cluster from the outside. We don't have to set up access for it, set the credentials for it, etc. So this is something InfoSec officers are usually very happy about. Another thing to note here is that all the configuration is stored as Kubernetes-native resources, so it's backed up by the etcd store of Kubernetes. And this gives you the opportunity to run in a database-less fashion. So whereas previously we had to have a running database instance that we connect Kong to store the routes, we don't need that anymore. And we can basically get rid of a little bit of management overhead for this database and run database-less. So I mentioned a few of these Kubernetes native resources like Ingress and so on. So in addition to these, Kong Ingress Controller provides a few custom resource definitions that we can use to configure Kong native things such as plugins, consumers, and so on. And these custom resource definitions can then again be enabled on the native Kubernetes ingress or service objects in order to modify their behavior. So in this example, for example, we see a Kong plugin here for the rate limiting plugin. It's based on the rate limiting plugin. And it is configured to enforce a rate limit of 5 requests per minute. So in order to use this plugin from an ingress, all you really have to do is add an annotation to your ingress object. So here you see an annotation with the key konghq.com/plugins referring to the reports API limit plugin, which you can see is named here, right? So once you connect your ingress to a Kong plugin like this, once you have traffic coming in for that ingress, Kong will take care of invoking the plugin on such access. On the right, you see a similar example for a service object, where once again, we have a plugin annotation pointing it at the Kong plugin defined on the upper right here. And this is configured to fire the basic auth plugin on access to this service. So one thing to note here is that a Kong plugin resource in this case is actually referring to a given configuration of a Kong resource, such as rate limiting plugin. So, for example, you could have multiple instances of the rate limiting plugin with different rate limits that are being connected to different types of ingresses. Another thing to note is that the Kong plugin resource is namespaced. So you also have another custom resource definition called Kong cluster plugin, and instances of that is available globally in the cluster. And that allows you to have certain plugin configurations which are available only in some namespace, while others are available globally in the cluster. So this approach is very cloud. I mean, it's cloud native. It leverages a lot of existing Kubernetes APIs and concepts, and it can help you avoid vendor lock-in as well. So it can help you, for example, migrate from other ingress controllers to Kong if you so desire. So the ingress resource itself is a Kubernetes-native concept, and you specify what ingress controller you want to handle it via this ingress class name attribute. For a very simple ingress like this, you could easily switch out the ingress controller with Nginx or Traffic or what have you, and things would still run fine. One thing that might complicate switching between different controllers is, of course, if you use controller-specific concepts and custom resources, such as Kong plugins, then you can't expect to see the same behavior if you switch to a controller. But it gives you the option to migrate more easily between different controllers, and it also allows you to run multiple ingress controllers where you have a subset of ingresses managed by a Kong, maybe a subset managed by another controller, if that fits your use case. All right, so now that we have a little background here on the Kong Ingress Controller, maybe it has already become a bit more clear how we can leverage this as a platform team. So just to rehash a little bit, our goals are firstly to have the same set of services and ingress routes running in multiple clouds. We also want to allow each application team to run their own services and self-serve ingress creation. We don't want the platform team to become a bottleneck. To counterbalance this, we still want to allow the platform team to exert some amount of centralized control to find and deny bad behavior or bad usage patterns. And we also want to allow the platform team to provide certain Kong resources, maybe plugin configurations, in a global manner to all the application teams. And that takes us to this diagram showing our multi-cloud configuration. So we are running our services across multiple Kubernetes clusters across different cloud vendors. So depicted here, we have one Kubernetes cluster in AWS on the top right, and we have another cluster in GCP below. And you can imagine another one for Azure. It's not depicted here, but you get the point. So we want to allow our customers to connect to either cloud here and be presented with the same API interface. On the left-hand side, you can see that each service team has their own set of GitHub repositories that they can add manifests to. And these manifests should in turn be published to their namespace in Kubernetes. These repos here are entirely owned by the application teams. There is no need for platform to shepherd changes here. And we can now more easily scale our organization by adding new teams and repos on the left-hand side here. Another big part of the puzzle here is that we went with a GitOps model. So in the middle here, you can see Flux running in each Kubernetes cluster. Flux is constantly monitoring changes to the GitHub repos shown on the left. So when there's an update, it will basically pull changes. And if there's an update, it will publish the updated manifests to the Kubernetes cluster. And this includes, of course, Kubernetes-native resources, such as deployments, services, and ingresses, but it can also be custom resources, such as Kong plugins and Kong consumers. And each application team, each GitHub repo can be configured to publish these resources into their own namespace in the cluster, so that you can actually lock down access with Kubernetes RBAC. So once these resources are added, the same flow that we saw earlier with Kong Ingress Controller monitoring changes to them and updating the Kong proxy in response will happen. So we have two quite nice reconciliation loops here. We have Flux reading from GitHub repos and publishing new manifests into the clusters. And then we have the Kong Ingress Controller monitoring changes to a subset of resources and updating Kong proxy in response to that. So if we contrast this with the previous solution where we had to point Terraform at a running Kong instance, GitOps is now allowing us a more pull-based approach where we don't need to configure access into the cluster for an external agent like Terraform. You have to give read access from Flux to the GitHub repos, and you can reach out and pull in manifests from GitHub rather than the other way around. For anyone who has a moderately complex Terraform setup, you might also know that we can avoid some issues with complex interdependencies between Terraform workspaces that could lead to them ending up needing to be run in a certain order, or if they're not, they might end up in broken states during things such as cluster bootstrap. But when we are using Flux to pull in the changes, once the cluster is up and running, Flux will get kicked off. It will fetch the manifest from the GitHub repos and publish to the Kubernetes API server, and everything is nice. So you might also notice here that both clouds are reading from the same source of truth, from the same set of GitHub repos. So that means we're able to set up the same routes and API interface in each cloud. I'll also note that we do have tooling that allows you to publish certain resources to only one of the clouds, but this is generally not used for ingress routes. Still, if you have some exotic use case, you are able to publish a unique route to GCP if necessary. So, as a platform team, we want to strike the right balance of providing good service to the application teams while still allowing them to work independently of us. So next, I'm trying to show a little bit about how you can manage ownership of resources in a given cluster. So the model we went with is that the platform team takes care of running Kong itself. So the Kong proxy, the Kong Ingress Controller. We take care of making the custom resource definitions available in the clusters. And we also publish certain plugin configurations that are useful to multiple teams. So an example you see here is this Kong cluster plugin here. And that means that other teams, such as Team A, if they create their own ingress, they're easily able to start using that Kong cluster plugin by referring to it via an annotation. At the same time, if you have a team with a bit more of an exotic use case that may not generalize to other teams, they're still able to publish Kong plugin configurations into their own namespaces and refer to them from their ingresses living inside the same namespace. So that gives a little bit of flexibility to the teams of still meeting their own unique needs. And if it becomes more of a cross-cutting kind of thing, you can promote it to a platform-owned, globally available cluster plugin configuration. And that takes us to the last slide with a few conclusions. So all in all, this approach works quite well for us. It is very flexible, so it allows us to find a good balance between team independence and centralized control from the platform team. This flexibility means that we can adjust according to need in the future as the number of teams and services grow, as the platform team itself evolves. In terms of security, we're able to isolate application teams in their own Kubernetes namespaces and utilize RBAC controls to lock down what they're able to do. We didn't mention this next part in detail, but we highly recommend using a policy agent such as Kyverno or OPA, and then you can add very fine-grained constraints on how teams are able to configure plugins and other Kubernetes resources. So as a few examples, you can have a policy that disallows Kong plugins to be sourced from Lua code stored in config maps. Maybe your organization has InfoSec officers who are not happy about that. You can create a policy to disallow it globally. You might also want to disallow or enforce the use of certain host headers or plugins. You can have policies for that. You might want to limit the range of certain plugin parameters. we saw the rate limit plugin earlier. Maybe you want to make sure that it's between a certain range. You can add a policy for that. Or you can have team or namespace specific policies to give more or less freedom to teams based on your own organizational needs. Lastly, we see that the new GitOps approach is very flexible. It allows us to more easily scale our organization. Manifests are pulled from inside the cluster rather than pushed in from an outside component, improving our security posture. And although we've had to add some extra tooling in order to safely promote changes between environments, I think the conclusion is that it has made our deployments safer, more predictable, and easier to roll back. And that brings us to the end. So I will hand it over to Adelina for some closing notes.
Hi, I hope you enjoyed our little walkthrough. We've left 2 resources here if you want to learn more about us and some of the things that we're building. So our podcast has a lot of like illustrious people that come and talk about their technologies and how we use their technologies as well. And our blog is written, our engineers take a lot of time writing about their own projects and also about their work projects on our blog. So definitely check it out as well. This is the end of our presentation, so like feel free to ask any questions. And if you'd rather not ask here, then you can always catch us online. So thank you very much.
Thank you so much, both of you. That was amazing. Let's check out the questions in the Q&A. We have 4 of them. Can you see them?
Yeah, I can read them out.
Yeah, just read.
So, yeah, which layer Ingress controller was implemented, layer 4 or layer 7?
So for us, it's layer 7. We're basically HTTP level traffic, so we only use layer 7.
Was Oracle or IBM also considered when we chose our cloud providers?
Right. So I think we did a consideration of multiple cloud providers, and we needed cloud providers that had good managed Kubernetes offerings. And I think there was a longer process there, but we ended up finding out that basically the industry leaders, so GCP, Azure, and AWS were the best fits for us.
Yeah, and I also want to make a little note that we don't choose the solutions alone as well. Like Form 3 makes our choices together with our customers. How do you respond to specific requests such as or specific use cases?
See,
so I imagine that configuring Kong using Ingress means having a lot of Ingress and annotation resources. Isn't that too complicated to manage?
I'm not sure if I understand the question completely, but I think part of the reason for wanting to decentralize some of the management is, to make it so that each team can manage their own Ingress resources. And that helps a little bit, right? So every team should be able to manage their own Ingress resources. And as the platform team, we're able to have policies that apply globally if you want to enforce certain ways of using them.
How have we chosen to monitor our Kong Ingress controllers in the different environments? Have we had any considerations to make the setup as simple as possible? Right.
So we're basically exporting Prometheus metrics, and we have Grafana Cloud. So we have all of these standard Kong metrics that we're using to create dashboards and set up alerting. And this is running in all different clouds. So you have a label for each metric indicating which cloud and which cluster the metric is from. So you're able to create dashboards showing, for each specific cloud exactly the different performance metrics there.
we've got Nat's Jetstream questions. What is your experience of Form 3 using Jetstream?
Yeah, it's an interesting question. So this is with another team within Form 3, so I can't give you a great answer. I think it's been a learning experience for us as well. We did a investigation of different options. We found out that Jetstream worked for us. We knew we needed to run a messaging provider across 3 different clouds. There's been a few battles along the way, but we've been able to work very well with Simion, the provider, and I think we got it into a good shape. But yeah, it's been a bit of a learning experience for sure.
And one of the reasons why we also chose Jetstream, I know we haven't focused so much about it, but it's those data centers. So we needed to run a very lightweight messaging broker that will not take a huge memory footprint. And Jetstream was really, or NAT in general, was really simple to run the NAT server and didn't take a lot of memory. So that was one of the main reasons that it was chosen. The next question is the Ingress controller open source or is it licensed?
It's a good question for Kong itself. I think I'm not actually sure if it is completely open source or not. I know the Kong API gateway itself is open source, but there's also a few components you need to pay for. So I'm not sure if Kong is able to say for sure here.
I think we use the open source components, and I believe we'll get back to you on that. Is SNI routing on TCP TLS connection supported?
So I think we need to check the docs here. We mostly have HTTP traffic for Kong. There is a custom resource definition called TCP route provided by Kong, and I would be surprised if they don't offer SNI routing.
Okay, regarding the cloud infrastructure around the Kubernetes cluster, do you manage SSL and WAF inside Kong, or do you leverage each cloud provider certificate management?
Yeah, so here at the moment we're using the cloud provider specific ones. So we have, for example, MTLS for connecting into us, and we need to terminate that before Kong. So that's also where we do WAF and so on.
I think there's one more question in the chat. Raphael.
Do Form 3 build custom Ingress controllers with webhooks for payment integration with third parties?
Ingress controllers with webhooks. We don't build any custom Ingress controllers. We rely on the Kong Ingress controllers. So I think the answer is no. Maybe I'm misreading your question a bit. What we do have is our customers are able to set up webhooks, and we're able to notify them of payment events out from us. But the Kong Ingress controller is not really involved in that part of the system.
All right.
Right. Well, sorry.
Yeah, no, I was going to say any last questions if anyone wants to ask last questions.
Lots of good questions, by the way. Thank you very much.
Yes, the recording will be uploaded to our YouTube channel. Let me give you a link really quick so you know where to look for it. It'll be available in like a couple hours today. So here I paste a link to the YouTube channel. You can find all of our recordings from all of our events there. All right. I think that's a wrap. Adelina, Frederick, thank you so much. This was very, very cool. I think everyone very enjoyed. Very interactive session as well. Thank you, guys. We'll gladly have you again join us sometime. Thanks to everyone who joined. Hope to see you at our next events. Have a great evening, great day ahead of you, and speak soon. Bye-bye.
Bye, everyone.
Bye. Take care.
Bye.